I am Mr. Ish and thank you for joining me for this video. We're looking here at this system of two equations, one of which is a linear equation, the other one is not. You have to find the solution of that particular system of equations. X squared plus y squared equals 9 minus 2x plus y equals 3. Your regular techniques here will not work because one is linear equation, one is not. If you were to graph these out just to get an idea of what you're dealing with, you can. The very first equation, x squared plus y squared equals 9, represents a unit circle. Think about it. X squared plus y squared equals r squared. You have a circle over there with a radius of 3. In all instances, you have a graph of that. And you're going to have these points 3, 0, 0, 3 because you have a radius here of 3. And then 0, minus 3. That's the first equation right over here. Now the next one, if you were to zero out the x, you'll have a y value here of 3. And then you're finding the solution over here, which means you're finding the intersection points of both of these curves or graphs. If you zero out the y, you're going to have minus 3 over 2. You have 1 point 0, 3 right over here. So incidentally, we have one intersection point already given to us by means of the sharing of points for both of these curves. But the other one, minus 3 over 2, 0, will be right over here in the middle. When you connect these two, you're looking at this. So you're basically looking at this intersection point and that. We already have one intersection point, but assuming we didn't have it, how would you go about solving this? And let's learn that technique. The best way of handling these type of questions is use the procedure of substitution. Look at this second equation, y is equal to 3 plus 2x. Take this value here and substitute in the first one. You have x squared plus 3 plus 2x whole square, because this here represents y and you're doing y squared equals 9. And now you have to open that up. When you open it up, it's not hard. You'll have a 9 plus 4x squared plus 6x times 2, which is a 12x, is equal to 9. Remember, this is a plus b whole square, a squared plus b squared plus 2ab. That's exactly what you have. Combine the common terms and bring everything and make it into a quadratic equation. 5x squared plus 12x. Bring the 9 over here, it cancels out. You have this 5x squared plus 12x equals 0. Isolate a 5x. It comes in here, 12 over 5 times is equal to 0. If you were to open this, you should end up with that. You have two separate equations here which equal 0. 5x is equal to 0, x is equal to 0, and then x plus 12 over 5 is equal to 0, and therefore x is equal to minus 12 over 5. That minus 12 over 5 would represent the x value for right here, this intersection point. The other one, 0, represents the x point for that. But you have 2 points coming out, and we have them right over here in terms of their x values. If you put 0 and minus 12 over 5 into any of these, you'll get your y values. Put 0 right here in this. You'll get y is equal to 3. So we have that one intersection point, but we already knew this from the very beginning, because incidentally it happened to be discovered right at the very beginning in terms of the graph. Now you have minus 12 over 5. You can plug this again in this equation. You have minus 2 times minus 12 over 5 plus y equals 3. You have here a 24 over 5 plus y equals 3, and then y is equal to 3 minus 24 over 5. You have a common denominator here of a 5. You'll have 15 minus 24 over 5, which is minus 9 over 5. And that's your other point, minus 9 over 5. What I will do is just clean up some of this mess. You already know how we determined these two x values right here. It was from this equation right here. So let me just clean it out. So if someone were to ask you what's the solution of this system right here, one of which is a circle, unit circle, the other one is this linear equation, it's this right over here. 0, 3 minus 12 over 5, minus 9 over 5. 0, 3 is this intersection point of the two curves. Minus 12 over 5, minus 9 over 5 is the intersection point of this part right over here. And both of these answers should be good. So this is how you would handle these type of questions. You're not going to use a regular traditional elimination technique and all of that. You'll have to do substitution primarily. And that's it for this video. Have a great day. Thank you for watching. Bye.